Hi, AP PreCal. It is Ms. Kosh. Today I am headed into AP PreCal's way of teaching rational functions. And basically what I did is I looked through 1.7, 1.8, and 1.9 and kind of pulled everything that had to do with limits or inequalities and the foundational stuff that we need for that. And that's what I'm going to teach to begin with. And so I made a chart because sometimes I like doing that. And so first of all, a rational function is analytically represented as a quotient of two polynomial functions. So I have some polynomial divided by another polynomial. So I'm going to give you a bunch of different examples, and then we're going to figure out the end behavior and kind of talk about what it looks like and kind of go from there. Okay, so when it's bottom heavy, so what do I mean by bottom heavy? And it's in quotes, it has a more official math way of saying that, but you know, whatever. When the degree of the denominator is larger than the degree of the numerator. So here I have a constant over a linear factor. Here I have a linear over a quadratic. These are bottom heavy. What you might remember from Algebra 2 is that they approach, it has an asymptote of y equals 0. Okay, and so in this case, this first one here was just the parent function, and I talked about that in my intro video that I did after the test. Okay, it looks something like that. It's kind of terrible. But what happens, the end behavior as r decreases without bounds, so the limit as x goes to negative infinity of r of x, well, what's it doing? As we get smaller and smaller and smaller, it starts approaching that asymptote, and so it equals 0. Okay, this one, as it increases, the limit as r goes to positive infinity, did I say r? I meant x. The limit as x goes to infinity of r of x will equal, what is it doing on this side? Well, on this side too, it's going to 0. Cool? Okay, on this one, we now have a linear divided by a quadratic, but it still has the same horizontal asymptote. So I don't know what it's doing in the middle. I mean, if we're really curious, yeah, I'm a little curious. Not a lot curious, but okay, I'm going to pull up my calculator from a second ago. Delete. This is the last video I just made. So hopefully you're watching that one. Okay, so x minus 2. This is just for extra fun. So if I draw this, let's make our window standard. Oh, it already was. Okay. So notice on this one, when we talk end behavior, I'm not overly concerned about what happens in the middle or what happens here. I'm just talking about as we go off to positive or negative infinity. So you might notice, hang on, let me change this window for a second. Our y values, let's go from like -1 to 3 for just a second. Okay, you can kind of see that there's something weird happening up here. Cool. It comes up and it actually, look at this, it crosses our asymptote, but then it turns around and really treats it like an asymptote. So when you were taught that you could never cross an asymptote, they kind of lied to you. You can't cross an asymptote at the extremities, you know, but sometimes things happen in the middle. So it's coming up and going over and then turning around and approaching it again. Okay, so let's come back to standard window. Okay, so the point was, since it's bottom heavy, we have an asymptote of y equals 0. So what's the limit as x goes to negative infinity of r of x? Well, it's going to 0. Okay, the next one, I'm running out of space. The limit as x goes to positive infinity of r of x would also equal 0. Okay, so whenever it's bottom heavy, we have an asymptote of y equals 0. You could write something like that, asymptote y equals 0. And so as you go off to both positive and negative infinity, you're going to approach this asymptote. Super. Now what happens when you have the same degree? So in these, I did this on purpose, so it's not just the leading coefficient. But if we rewrite this, this becomes 3x plus 7. I did that on purpose. Over 2x minus 1. And now with this one, how do I want to explain this to you? As my x gets ridiculously large, I'd have 3 times something ridiculously large plus something that no longer really matters. Like if I plugged in 1 million or 1 billion, I would have 3,000,000,007. Okay, the 3 billion is significant, the 7 not so much. If I plugged in that same billion in the denominator, I'd have 2 billion minus 1. Okay, 2 billion minus 1, it's like, oh look, our federal deficit, we've paid $1 back. Just kidding, not funny. Okay, basically I have this 1 and the 7 don't really matter, okay? And so it'd be like having 3 billion divided by 2 billion, which would simplify out to just be 3/2. And so what happens here is this one is going to have an asymptote of y equals 3/2. So anytime it's the same degree in the numerator and the denominator, we're going to divide our leading coefficients. And it's not just what came first, it's the part that's with the x or whatever. And so the limit here, as x goes to negative infinity, I think that's the first one, decreases without bound, of r of x is going to equal that asymptote 3/2. Then also the limit as x goes to positive infinity of r of x will be equal to that same asymptote 3/2. Okay, so here the note in the summary is divide leading coefficient. Okay, I'm too lazy to write it out, but divide leading coefficient, and it's going to be y equals whatever is your asymptote. Those notes are less than perfect, but hopefully I'm making sense to you. On this next one, I see the same degree. They both had x squared. I was very intentional. I wanted it all to fit in my box, so I put little short messes in there. Anyway, whatever. And so when I divide the leading coefficients, this is going to have an asymptote of y equals negative 2/5. You can put the negative at the bottom. I'm just afraid we'll lose it. I either put it at the top or at the side. So the limit on this r of x as x goes to negative infinity of r of x is equal to a negative 2/5. And the limit as x goes to positive infinity, that was a negative infinity right there, by the way, of r of x is equal to my asymptote again. Isn't that fun? Okay, the next one, now I see situations where they're top heavy, and so the degree of the numerator is larger than the degree of the denominator. And so we talked a little bit about this in my intro video from before. Anyway, if it's top heavy, we end up having a slant asymptote when it's 1 degree bigger. Or notice on this one, I have an x cubed divided by an x, and this is going to give me a parabolic or a quadratic asymptote. So this one, so let me show you. I needed more paper. Let me show you what I'm talking about. If I come along here, and this is a great one to do synthetic division. Notice I have no x's in this because it didn't fit in my square. That's the whole truth of it. I have not divided this one yet. I have 3 times negative 1 is negative 3. Add this is negative 3. This gives me a 3. This comes down to 5. What I can do is I can rewrite this r of x as being 3x minus 3 plus 5 over, what was my denominator? X plus 1. So this part right here, as x gets ridiculously large, we have 5 divided by something ridiculously large, goes very, very small. So this part is my slant asymptote. And the slope of this is positive. So what's going to happen is that as I have this slant asymptote and I have a horizontal asymptote, I lied, I'm just testing you. I have a vertical asymptote like this. I don't know why I didn't make them dotted. But whatever I do, I'm either going to be living, I'm either living here and here, or I'm living here and here. Okay, and so in either case, as my x goes to negative infinity, I'm going to follow the shape of this line. Okay, I'm either following the shape of the line from the inside here or from the bottom here. This arrow is getting closer and closer to the vertical asymptote. This one's getting closer and closer to the vertical asymptote, but this is what has an end behavior, and it's following the shape of this line. I didn't do a great job of drawing it, but hopefully that makes sense. And so because this has a positive slope, what we're doing is as we go in the negative direction, we would go negative. As x goes negative, y goes negative. As x goes positive, y goes positive, because we're following the shape of that. And to be honest, I can determine my end behavior. The limit, this first one is as it goes to negative infinity of r of x. And then my second one is the limit as x goes to positive infinity of r of x. I can determine that just by knowing it has a slant asymptote and the slope of the slant is positive. That tells me that I'm going to go to negative infinity when I'm going, as x goes negative, y goes negative, and then as x goes positive, y goes positive. Okay, so slant or parabolic. I'm a terrible speller, but there we go. I think that one's spelled correctly. Okay, so I think that's kind of cool. So we didn't have to graph anything. We don't exactly know what it looks like, but we do know what its end behavior is. Let's look at the other one. On this one, do I want to change this halfway through? Yeah, I'm going to change it because this one was positive, and this, if I divide, I'd get another positive, and I'm going to make it negative. So I'm going to make that negative halfway through. Maybe I'll have changed it on the notes before we start. Maybe I won't. We're dividing by a linear again, so I can do synthetic division again. I have a cubed term, but no square, no linear, and then there's this. And so negative 2 times negative 4 is positive 8. Bring this down. Oh, this is going to be annoying. 8 times, that is a negative 32. Yes, okay, bring that down, and then this becomes something positive, and so, but positive and big, and so this is still positive. The reason I don't care, this is terrible, but the reason I don't care is that we end up getting this equation, our r of x is now equal to a negative 2x squared plus 8x minus 32 plus something right here that's going to go to 0. It's something over, what were we dividing by? X plus 4. I don't really know or care what that number is, but it doesn't really matter because it's whatever. I mean, you can comment below if you figured out that number, but I just don't feel like wasting the brain power. What I do know is that now I've got an asymptote that's a parabola that's opening down. Okay, and so somewhere I might have, I don't even know where it is or what it looks like, and somewhere else I have a vertical asymptote. So my graph either lives, like these are the asymptotes, so it either lives within this world or out here, or, okay, if it's here, it's going to live out this side. If it's here and here, it would live like that, okay? And so, but the cool thing is that it's going to follow the shape of this parabola. Since the parabola is a even degree and a negative leading coefficient, they both go to negative infinity. Okay, so I don't even have to know what the graph looks like to know that the limit as x goes to negative infinity of this r of x is equal to negative infinity, and then the limit as x goes to positive infinity of r of x is also equal to negative infinity. Okay, I think those are cool. I hope you enjoy that. What are we doing next? Come back for the next video, because the next thing I'm going to talk about is we're starting to look at the vertical asymptotes and that sort of thing. So I'll see you in the next video. Good luck. Go study. Go practice. Like, subscribe, comment, tell me nice things. Goodbye.